Hello from West Virginia. I don't know if I've ever seen one of these in West Virginia. But that's okay, because we have Joke of the Day, and Joke of the Day makes everything okay. So, in light of where I am, how do you make a tissue dance? You know, like a Kleenex tissue, blow your nose. How do you make a tissue dance? You put a little boogie in it. Oh yeah, a little boogie. Okay, we are going to dance our way into part 2 of using linear equations to solve word problems. And we're going to look at a specific type of word problem that's a break-even point. Because a lot of times in life, we need to figure out, okay, we've got two situations. Where are the two going to meet up? Where is the break-even point? So I've got 3 examples that I'm going to walk through with you. And you know that when you have a word problem that you need to attack, you need to read it in its entirety one time just to get a feeling for what's happening. And then just slow it down. Take it sentence by sentence. Biggest problem that I see people making mistake that I see people making when they're dealing with word problems is they just kind of freak out and they try to barrel through it. Just slow down, think carefully and methodically, and you will get there. So let me show you how that goes. We're going to read it in its entirety once. So Miko is joining a gym because we're all ready to get healthy, aren't we? Gym A has a joining fee of $80 and then charges $12 per month. Gym B has a joining fee of $20 and charges $16 per month. Well, notice that Gym A has a much, much higher joining fee, but Gym B has a little bit of a higher monthly fee. So at some point, we're going to get a break-even point. We want to know how many months will the cost of each gym be the same, because that might determine which gym Samiko wants to join. So we've read in its entirety. We got a feeling for what's happening. We want the idea of equality. So what we want to happen is we want the cost of Gym A to be equal to the cost of Gym B. That's what we want to know. When are the two costs going to be the same? So now let's figure that out slowly, sentence by sentence. Let's start with that first sentence. Well, this tells us that she's joining the gym. That's not really going to help. Second sentence says that the Gym A has a fee of $80. Now that's a joining fee. So does that fee need to be paid over and over and over again? No, that is a one-time cost. So we've got this $80 cost here, but there's more to it because notice that it also says that there's a $12 per month charge. Now, how many months is Samiko going to be in that gym? Not sure. Hopefully she'll stick around a long time. But you know how it goes. Some of us, we make that New Year's resolution, we're out within 2 months. So we're not really sure how long this is going to last. Aha! There is our unknown. And when you figure out what your unknown is, you need to define it by a variable. So we need to figure out how many months this is going to last. Let's get a variable to represent that. I like to be creative because it helps me remember. So I'm going to let M equal the number of months. So what happens here in that Gym A is it's $12 for each and every month. And we've looked at this idea before, that it's going to be $12 in the first month, another 12 in the second month, another 12 in the third month, another 12 in the fourth month. Rather than adding up 12, 12, 12, 12, 12, what would be faster? Yes, multiplying by 12. So what I'm going to do instead then is I'm going to take the number of months, which I don't know, I'm calling M, and I'm going to multiply it to 12, giving me a 12M, and that's going to tell me the total of all those monthly fees. And remember, I'm going to take this total of monthly fees, I'm going to throw it in with the joining fee. Putting those two together will tell me the cost of being able to work out at Gym A. So putting them together, how do we indicate that? Yes, that would be addition. So now let's take a look at Gym B. So what happens in Gym B is we've got, yet again, a joining fee. That's that one-time fee that doesn't happen over and over and over again. One-time fee of $20 for Gym B, but then notice it's $16 per month. Now, once again, 16 and 16 and 16 and 16, it would be faster to multiply 16 to the number of months. Well, how many months is this one lasting? I'm laughing. How many months is this lasting? I'm not sure. But what I do know is I want it to be potentially the same number of months since I don't know, I'm still calling it an M. So I'm going to take my 16 and I'm going to multiply it to M, and that will tell me the total of the cost here for Gym B, the total of the monthly fees. So I've got my joining fee, I've got my monthly fees. Once again, I'm going to put them together, and when I put them together, that is the total cost for Gym B. So we have the total cost of Gym A, we got the total cost of Gym B. What do I want to happen here? Yes, I want the two to be equal to each other. So at this point, I have done the hard part. I've set up my equation. Now all I have to do is solve that equation. And you know how to solve equations. We're going to get all the variables on one side, all the constants on the other side. And remember, it does not matter which side you get your variables on. It does not matter which side you get your constants on. Just get them separated. So I think I would like to subtract that 12m and get all my variables on this side, largely because when I take a 16m and minus a 12m, I don't get a 4m. If I would have subtracted that 16m, I would have got a negative, which is okay. We know how to deal with negatives. I just prefer not to if I don't have to. So on this side, I have a 20 plus a 4m. On this side, I have an 80. I sent all my variables on this side. All my constants now need to go over here. So at this point, what I'm going to do is I'm going to subtract a 20 on each side. And 80 minus 20 will give me a 60, giving me 60 equals 4m. And you know what to do at this point. I'm just going to go through and I'm going to divide by 4 on both sides. When I take a 60 and divide it by 4, I get a 15. That is my m. But we're in a real world situation, so we need those units. It's 15 what? Months. And remember, that's why it's so important to define that variable, because if we forget what that stood for, just go back and look at how you defined it. So 15 months is when we will have that break-even point. Now, how can I check and make sure it's right? Absolutely. Plug that thing back in. When I take a 12 times a 15, 12 times 15 is going to be, 12 times 15 is, hold on. Sorry about this. Let's see here. 12 times 15 is 180. 180 plus 80 will give me 260 over here. And then when I do 12 times 16, let's see here. 12 times 16 is 15. I'm sorry. 15 times 16, my apologies, is 240. 240 plus 20 is once again 260. So you can see we did get the same thing on both sides of the equal sign. Once we plugged our 15 months in, we know that that's the correct answer. All right, so let's take a look at another example here. Okay, so here's our second example. Let's read it in its entirety to get a feeling for what's happening, and then we're going to take it slowly, sentence by sentence. So Jalen and Keon work for the same trucking company. They are both heading to the same destination, and thus they're going to drive along the same interstate. Now Jalen leaves headquarters before Keon, and he drives 60 miles an hour. After he has driven 65 miles from those headquarters, Keon leaves and drives 70 miles an hour. Now Keon's speed is faster. He's driving 70 miles an hour, and Jalen is driving 60 miles an hour. Since Keon's speed is faster, he will eventually meet up with Jalen. We want to know how long will that take for the two to meet up. So we've read it in its entirety. We've got a feeling for what's happening. And we know that what is happening here is we've got Jalen driving along like this. And we've got Keon going along the same route. And we want to know at what point will they arrive at the same spot. So what we're doing here is we're mapping out their distance, and we want to know, okay, once we figure out Jalen's distance and we figure out Keon's distance, what do we want to happen with those two distances? And here's Keon's distance. What do we want to happen with these two distances? We want them to be the same. We want to figure out at what point will these two distances be the same. So we've got our feeling for what's happening. We're going to take it slowly, sentence by sentence. Now the first sentence simply says, okay, they work for the same trucking company, which is not particularly helpful for setting this up, but it does help to know that they do have the same starting point. Plus, they're both heading in the same direction, driving along the same interstate, which again doesn't really set this up, but it does help to know that they're not taking different routes. Now, here's the real meat of it. Jalen leaves headquarters before Keon. He drives 60 miles an hour. 60 miles an hour for Jalen. Now, in order to figure this out, there is a formula that we need, and it's our distance formula. The distance formula says distance equals rate times time. This is distance, and this is rate, typically miles per hour. This is time, and time is always in hours. So in order to figure out Jalen's distance, we're going to use this formula. We're going to take Jalen's rate, 60 miles an hour, and we're going to multiply it to the time that he has spent driving. Well, do we know how long Jalen has been driving? No. And there's our unknown. When you figure out what that unknown is, define it by a variable. I like to be creative, just to make it easy for me to remember what the variable stands for. So I'm going to let my H equal the number of hours traveled. And so in order to figure out Jalen's distance, we're going to take, again, his rate of 60 miles an hour right here. We're going to take the time, which I'm now calling H, and that is going to give me Jalen's distance. Now, let's think about what happens here. After Jalen is 65 miles from headquarters, so after he's already 65 miles down the road, Keon begins. Okay, so Jalen has already traveled, taken that distance and progressed 65 miles. So we better tack that on to Jalen's distance of 65 miles, and now we can say, okay, what's Keon doing? So it says now that Keon leaves and he drives 70 miles an hour. So now with Keon's distance, we're once again going to use our distance formula here, and we're going to use a rate of 70 miles an hour. How long is he driving? Once again, I don't know, so I'm calling it hours. And I want those hours, the hours are going to be the same because I want to know how long is this going to take. So Keon's distance then is going to be 70 times that H, and like we said, we want it to be equal. We just did the hard part. We set up our equation, now all we have to do is solve it. Remember, to solve your equation, you need to separate your variables and your constants. It does not matter which side you get the variable on. It does not matter which side you get the constant on. But notice your constant is already over here, which means let's just slide this 60H over to the other side, quick and easy like this. And when I slide that 60H over, I have 65 equals 10H. And we now know what to do to get that by itself. Let's just go through and divide both sides by 10. And 65 divided by 10 is going to be a 6.5. In other words, a 6.5. Now, 6.5 what? That's why we defined our variable, 6.5 hours. And remember, that's one of the greatest reasons for defining that variable, because you should always include your units to show how smart you are. One, so that the reader knows this is hours, it's not trucks, it's not people, it's not miles. It's going to be 6.5 hours. The reader needs to know that. But more importantly, the reader needs to know that you know that it's 6.5 hours. You need to impress that reader. Show off how smart you are. Put your units in there. And if you're not sure what the units are, go back to how you define that variable. Now, we always need to check and make sure, did we really answer what we were supposed to answer? I should have done that in the previous example, and I failed to do that, and I apologize. The question asks, how long will it take for the two to meet up? It will take 6.5 hours. We can double check that. If we take 6.5 and multiply it to 60, well, 6.5 times 60 is 390, and then 390 plus 65 is going to give us a 455 over here. And if we take 70 times 6.5, well, 70 times 6.5 is, again, 455. So this does give us the same distance, so we did in fact answer the question. And if we flip back to our previous example, notice that the question that was asked in the end says, after how many months will the cost be the same? And we did figure out it took 15 months for that cost to be the same. When we double checked it, it was the same cost. We did answer the question. I just need to point that out because sometimes the variable that you get is not really the question that needs to be answered. Perhaps the question is, after how many months, what will the cost be? Well, then we need to get our months, we need to plug it back in to figure out what that cost will be. Similarly, it could be that the question asked here is not really how long will it take, but after that long, what will the distance be? So you always need to double check and make sure that you did answer the question you were supposed to answer. Okay, I've got one more for you. Okay, and here's our last example. We have a tank that contains 340 gallons of brine. It's being drained at a rate of 15 gallons per hour. Another tank, which starts with 60 gallons, is being filled at a rate of 20 gallons per hour. After how many hours will they both hold the same amount? Here we have yet another break-even point example. So we've read it in its entirety, we've got a feeling for what's happening, and we know that what we want to happen is we've got one tank here, and we've got another tank here, and in the end, we want the two tanks to have the same amount. Don't ever hesitate to draw a picture. I draw pictures a lot. A picture's worth 1,000 words. You noticed in the previous example, I drew that little timeline for Jalen and Keon. It helped me to visualize what was going on. So I will always draw pictures. Don't hesitate to do that. But this is the general idea of what's happening, and now we're going to break it down sentence by sentence. So it says that our first tank contains 340 gallons of brine. Well, let me make these tanks just a little bit bigger so I can visualize a little bit better. Okay. So this tank starts with 340 gallons, and notice that it says that it is being drained at a rate of 15 gallons per hour. Now, what happens when we're draining this? Yes, the brine is coming out. Okay, now when the brine comes out, it's coming out at a rate of 15 gallons per hour. Now, it says that that second tank, this one, starts with 60 gallons, so it's starting down here with 60 gallons, and it says it's being filled. All right, so it starts with 60 gallons and is being filled at a rate of 20 gallons per hour. So what happens if it's being filled? Yes, we're putting brine into it. So brine is coming into it at a rate of 20 gallons per hour. And now we want to know, after how many hours will these levels be the same? So let's think about what's happening here. In this first tank, it starts with 340 gallons. And remember, we want the amounts to be the same. So this 340 gallons, I'm taking out brine. And how do I indicate that I'm starting with 340 and I'm removing brine? Yes, that is subtraction. So I'm taking it out, but notice the way I'm taking it out is a rate of 15 gallons per hour. Well, that means in the first hour, it's lost how much? 15 gallons. Now, I'm not asking how much is in the tank. I'm just asking how much is lost. In the first hour, 15 gallons. In the second hour, how much is lost? Not how much is in there, but how much is lost? Yes, 30 gallons. In the third hour, how much is lost? 45 gallons. In the fourth hour, how much is lost? 60 gallons. How are we getting 15, 30, 45, and 60? Yes, we are adding 15 every single time, but what if I go all the way up to like 23 hours? I don't want to go 15 plus 15 plus 15 plus 15 23 times. What would be faster? Notice I said 23 times. So I'm going to take the number of hours and I'm going to multiply it to 15. Well, how many hours is this taking place? Aha, there's my unknown. I don't know. So I'm going to define that unknown with a variable. So let's let, and I like to be creative, let's let h equal the number of hours. I'm sure you're noticing that the previous example was hours, and this is as well hours, but this is a different concept here. The previous example was traveling. This is filling tanks. So it's different concepts, but still using hours, and that's okay. But we said we're going to take 15 and we're going to multiply it to the number of hours, h, and that's going to tell us how much is being taken out, starting with 350, taking out this much brine. So that tells me how much is left in this tank after that many hours. Now, let's take a look at the second tank. It starts with 60, but notice we're filling it. How do we show we're filling it? Yes, we're going to add. Now, what we're doing is, in the first hour, we're adding 20. In the second hour, another 20. In the third hour, another 20. In the fourth hour, another 20. We're adding 20 every single time, and once again, what would be faster? Yes, let's multiply 20 to the number of hours. Still don't know how many hours, but it's going to be the same number of hours. So I'm going to multiply 20 times that h. This tells me how much is being added to the initial amount of 60. So this is how much is in this tank after this many hours. This is how much is in this tank after that many hours. What do I want to know about the two amounts? Yes, I want those two amounts to be the same, so I want the two to be equal. And we just did the hard part. We just set up the equation. That's the hardest part. Now all we got to do is solve it. And you know, to solve that equation, separate your constants and your variables. And like I said before, it does not matter which side you put your constants on and which side you put your variables on. So let's play around a little bit. I tried to keep my variables positive before, but I'm going to play a little trick on you. I'm going to subtract 340. Now, when I take 60 minus 340, I'm going to get a negative 280. And then at this point, notice that I put all of my constants on this side. I'm going to slide all my variables on this side. Totally fine if you said, now wait a minute, I added 15 to both sides and got a 35H over here, and then I subtracted 60 and got a 280 over here. You're going to be fine. You watch. So I put all my constants over here. That means all my variables go over here, which means I need to take this 20 and subtract it off, minus the 20H here. And a negative 15H minus 20H is going to be a negative 35H equal to a negative 280. And remember I said that if you would have added the 15H, you would have got a positive 35H. You would have subtracted a 60 and got a positive 280. But see here, what I'm going to do is I'm going to divide both sides by that negative, and negative divided by negative is going to give me a positive. So it's going to be perfectly fine. And when I take a 280 and I divide it by a 35, I'm going to get 8. Now, 8 what? Once again, show how smart you are. Put those units in there. Show off your intelligence. 8, remember that stood for hours, so 8 hours is going to be my H. And like I said before, I tend to get trigger happy and I start circling and I need to back myself off and I need to go back and say, did I answer what I needed to answer? After how many hours will they both hold the same amount? 8 hours. Let's double check and make sure that that's right. Put an 8 in here. Well, 15 times 8 is 120. And 340 minus 120 is going to be 220. Now, put your 8 here. 20 times 8 is 160. 160 plus 60 is yet again a 220. So sure enough, that is the right answer. So I hope this helps with your word problems when you're dealing with those break-even points. And remember, with any word problem, whether it be a break-even point or any other type of word problem, just slow down. You can do this. You really can. So read it in its entirety to get a feeling for what's happening. Set that up. Draw a picture if you need to draw a picture. There's nothing wrong with drawing a picture. And then just take it very slowly, sentence by sentence, being careful that you might not need to use every piece of information that's in there. In the examples that I gave, we did, but you won't always. So just be thoughtful about what you're doing, and you will get there. I hope it helps. Have a great day.